Hello students, welcome to Physics Pathshala. Today we will study on vector. Vector is a concept to specify a physical quantity, its magnitude and direction. All the physical quantities we come across in physics are categorized in two groups. One is quantities having only magnitude and quantities having both magnitude and direction. If quantities have only magnitude and no direction specified, we say these are scalar quantities. Whereas all physical quantities which has both magnitude and direction are termed as vector quantities. Now that means a scalar quantity will have its magnitude only, whereas vector quantities will have both magnitude and its direction. In this we will study categories of vectors, types of vectors and operation of vectors. Categories, we have two categories. One is polar and another is axial. In operation, we will cover addition or subtraction of vectors and product of vectors. In product, we will have two types again, that is dot product or scalar product of vectors, and another one is cross product or vector product of vectors. It's a dot in between two vectors. It is the cross between two vectors. Vectors are usually represented by a letter. Let is a force. For force we write F and an arrow over it. If there is no arrow and it is a simple letter, it represents a scalar quantity or only specifies magnitude. If arrow is given, it is a vector quantity. It will have its magnitude and its direction. Magnitude is the modulus of that quantity, or it is absolute value. Absolute value is some numeric number with its unit. Magnitude gives the absolute value or amount of the quantity. It does not specify the direction. Direction is indicated by the arrow over that quantity, and it has its start point and in a direction to proceed. That means it will have its start point always, and at the end arrow is indicates the direction of the quantity. Whereas any quantity have magnitude only are termed as scalar quantity. Scalar quantity will have a numeric value with its unit. All the quantities in physics will categorize under as vector quantities or scalar quantities. While in operation of vectors, we say it is addition. Then for addition of vectors, we will have triangle law of addition, parallelogram law of addition, and another one is polygon law of addition. All vectors will obey this law of addition. Law of addition indicates if we have a number of vectors acting, then it will give the final result or resultant vector. We can find out using this addition, that's using this law of addition. Law of addition, we can get resultant vector or the final output of all the vectors. Under types of vectors, we can have equal vectors, negative of a vector, third is modulus of a vector, unit vector, fixed vector, free vector, collinear vectors, coplanar vectors, coinitial vectors, coterminus vectors. The last one is zero vector. Here, say two vectors are equal if they have magnitude equal and direction also equal. That means direction in same direction and have both same magnitude. We say these vectors are equal. That means magnitude same and direction also same. Negative of a vector says if magnitude same and direction is opposite, then this vector will be termed as negative vector of the earlier vector. Modulus of a vector is the magnitude. The magnitude or numeric value, magnitude of the vector is termed as modulus of the vector. Unit vector is vectors having its magnitude 1. Any vector whose magnitude is 1 but vector will have its direction where magnitude will be 1 will be termed as unit vector. Same way, vector having magnitude 0 but it will have its direction, it will be termed as 0 vector. Now, vectors, any vector whose initial point is fixed, its initial or starting point, initial point is fixed, will be termed as a fixed vector. If the initial point is not fixed, initial point is not fixed, then it will be termed as a free vector. And now, if the vectors are acting in same line or along parallel lines, one vector and another vector both are in same line. In other case, one vector and other one is parallel to this, then it will be termed as co-linear vectors. And if angle between them is theta equal to 0 degree, it will be termed as like or parallel vectors. Again, if it is parallel but theta is 180 degree between them, or one is in opposite direction to the other one, this will be termed as unlike or anti-parallel. If theta is 0, then it will be termed as like or parallel vectors. If theta is 180 degree, that's one is opposite direction to the other vector, it will be termed as unlike or anti-parallel vectors. Now, if vectors are acting in a same plane, then all these vectors will be termed as coplanar, same plane. On same plane of the paper, we say plane of paper is one plane and all vectors lies on that same plane. If all the vectors having same initial points, or it is same starting point, then it will be termed as co-initial. Initial points are same. Initial point or start points are same. Then these vectors will be termed as co-initial. If all the vectors will terminate at same point, or terminate points are same, it will be termed as coterminous vectors. Let us discuss on what is zero vector and its properties. As it indicates, vector means it has direction. Zero indicates magnitude is 0, and it will be represented as 0 with a arrow overhead. Now properties of 0 is, if one vector added with 0 vector, the resultant will be same vector. And if any numeric is multiplied with 0 vector, it will have again a 0 vector. Magnitude will not increase and direction also will not change. If any vector is multiplied with numeric 0, then the numeric value becomes 0 and it will have some direction. That means the resultant will be a 0 vector. Example, we know position vector is the position of any object or particle, and it is calculated with its distance from origin and in which direction it is, or the angle it will make to some reference axis, let it is x axis. Position vector of point P will be OP. That means it will indicate P is located at a distance OP from origin and at an angle or in a direction that which will make angle theta with x axis. This is the position vector. This is position vector of point P. If the P lies at origin, position vector of a point at origin is have its direction but magnitude 0. Now let us study on unit vectors. Unit vector indicates quantity will have direction and magnitude of the quantity will be 1. Now, to represent any location or point, we use some coordinate. If only one coordinate is used, it is one dimensional. If two coordinates are used, let x and y, position of P will have how much it has crossed from origin, let x, and again from origin how much it has gone in y direction. If it is y, it will be pxy, and coordinate of that point P will be x and y. It is a two-dimensional expression of the position. Here point P, if it is only x-axis, how much it has crossed from origin O, if it is x, it will be the position of the point, or position of a point will be clarified if value of x is known. Here in a plane, we need to find out both the value of x coordinate, y coordinate to locate the position of the points. It is two-dimensional and it is Cartesian coordinate where both axes, x-axis and y-axis, are mutually perpendicular. It is called two-coordinate system. Two-coordinate system where we have its origin, we will have its two axes. In space, if any object is moving, it will cover some distance in its x-axis. Again, it will move certain distance in y-axis, again in z-axis. Then the position P or point P will have x coordinate if it has crossed x. If it has crossed some length of y, then its y coordinate will be y, and again it has crossed to z, then it will be z. This will be the coordinate of P using three coordinates. Hence it is termed as three coordinate system or three-dimensional. We'll be considering 3D, where we'll have x-axis, y-axis and z-axis. Now, as we told, unit vector has magnitude 1. Now, any vector along x with magnitude 1, we'll say it is I vector and it will be represented with a cap over it. That is, I cap is the unit vector along x-axis, whereas j will represent unit vector along y-axis and z will represent unit vector along z-axis. All of the vectors can be represented using this unit vector I, j and k. K is the unit vector along z-axis. Now to find out properties of these unit vectors, we say as I, j and k are mutually perpendicular to each other or orthogonal, because One is along x-axis, that is our I. Another one is along y-axis, that is our j. Another one is along z-axis, that is k. As we know, all three axes are perpendicular to each other. Now we say the angle between I and J is 90 degree. J and K is 90 and K and I also 90 degree. That means if it is sin theta is equal to sin 90, it will be 1. If it is cos theta, then it will be cos 90, so value will be 0. Using this we can proceed ahead. Now study on laws of addition of vectors. Purpose is, if a number of vectors are acting, we need to find out the resultant vector. This resultant vector can be found out using laws of addition of vectors. In this we are using three laws. One is laws of triangle, there is laws of parallelogram, and another is laws of polygon. In triangle law of addition, you say if two vectors represent two sides of a triangle in order, then the leftover or third sides of the triangle in opposite direction, opposite order. If we have chosen order in this anti-clockwise, now it will start from O to P, this vector A, then P to Q is vector B. Order will be Q to O, but in opposite order, the OQ represents the resultant vector of A and B, let it is R, OQ or R. Vector A is OP, vector B is PQ. This is the resultant vector of these two vectors, whereas its value magnitude is OQ and direction is from O towards Q. This says the triangle law of addition of vectors. In parallelogram law of vectors, let us have one parallelogram. If two sides of parallelogram, one is A and another is B, then this B is, let it is B. The resultant vector will be the diagonal of this parallelogram. In this case, the resultant vector is the diagonal of the parallelogram. Here A vector is A represents one side of the parallelogram, vector B represents another side of the parallelogram, then vector say R which is equal to OQ, the resultant is OQ, represents or R will be A plus B, or OQ will be as OP plus PQ. In both method, either it is triangle method or in parallelogram method, will have same value for its resultants.